All right, lesson 4.5, writing equations of parallel and perpendicular lines. So to go along with all three of those forms of equations that we've been talking about, there are different ways that we can look at these lines. So we have parallel lines, and if you think of parallel lines as railroad tracks, they never cross except at certain intersections. But two lines are parallel if they never cross. In geometry, we get into a little bit more detail and we say that they have to be coplanar, but everything you're going to see in this class is going to be coplanar. And so that just means that if these two lines are extended in either direction, then they will never cross or intersect or touch, so that means that they're parallel. So two non-vertical lines have the same slope and they're parallel. So when we're looking at equations, the most important thing of the day is looking at the slope. The slope will tell us everything that they need to know. So if two non-vertical lines have the same slope, then they are parallel. Okay, so when we get to that, we're going to make sure that they have the same slope. Okay, if two non-vertical lines are parallel, then they have the same slope. So they're just, oh, I wrote same again, same slope. Okay, so these are just converse statements. So if they do not cross, they're called parallel lines, and that means they have the same slope. Now, we did have this non-vertical exception. Well, if you remember, the slope when they are anything other than non-vertical. So right now this is a positive slope, they have a negative slope, right now they have zero slope, but if they have a slope like this when they're perfectly up and down like this, then they have no slope. It's undefined. We divide by zero, bad things happen. So we just have to make sure that if two things are vertical, they have no slope, so you can't compare the slopes. But even though these are two vertical lines, they are still parallel. And that's what those little red arrows mean, that they're parallel. Perpendicular lines is a little bit tougher, but not much. They do cross, but they don't just cross anyway. So here's a line that crosses, and then here's another line that crosses. These two cross, but they're not called perpendicular. They're called perpendicular whenever they cross in a special way, whenever they cross exactly at a T or at a right angle. That's the important thing. So if this angle right here is a right angle, then they're called perpendicular. So as far as we're concerned with the equations, if two non-vertical lines have slopes that are opposite reciprocals, then the lines are perpendicular, and if two non-vertical lines are perpendicular, then the slopes are opposite reciprocals. So here's what I mean by that. They need to be opposite and they need to be reciprocal. So opposite means different sign. So because this 3 right here is a positive 3, our new 3 is going to be a negative. And I'm going to write it on the bottom because I don't have a lot of room. Okay? But it's not just going to be negative. The reciprocal means I need to flip the orientation of numerator and denominator. So right now this is a 3, and even though you don't see it, it's a 3 over 1. So what I'm going to do, I'm going to write 1 over 3. But it needs to be a negative 1 over 3. Both of those things have to happen. It needs to be flipped, and it needs to be the opposite sign of what it was before. So this negative 7 would become positive 1 over 7. This 1 over 2 would become a negative 2 over 1. I don't even have to write the over 1 part because 2 is the same thing as that. And then this negative 2 over 3 becomes positive 3 over 2. So when we're looking at these equations, we want to write an equation that passes through this point and is parallel to this line. Now, I don't care much about this line right here. I only care about one thing, and that is the number in front of the x, because that will tell me what the slope is. And even though there's no number, I know that the slope is a negative 1. I don't care about that 2 at all. I don't care about anything else except for that slope. So my old slope is equal to negative 1. Well, my new slope, because it needs to be parallel, then it's going to be the exact same slope. So my new slope is actually the same as the old slope. So when I write this down, it's going to be y equals negative x. Well, that's the same thing. The only thing that might change is that plus 2 at the end. It has nothing to do with what r is going to be, but I don't know what it is now. It's going to be different probably. So in order to figure out what that is going to be, I'm going to use the point that they gave us so that I can plug them in and solve for my b. So I'm going to plug in that 6 where the y is and that 2 where the x is, and then see what I get. So y changes to 6 equals negative, I'm going to put that in parentheses so I don't forget the negative part, 2 plus b. So now in order to solve this, I need to add 2 on both sides, and I get my b is equal to 8. And now that I have my b, I'm ready to write the whole thing, y equals negative x plus 8. And that's going to be my final answer, because I don't believe it says which equation. Nope. So I'm just going to write that down and move on. Okay, now this one, you know what, just for practice, let's pretend that we want this to be not parallel, but perpendicular. Just so we get some practice doing that. So, again, the only thing I care about in this thing is the number in front of the x. I don't care about that 1 at all. It has nothing to do with what I'm going to come up with. So, that 2 over 3, the old slope is 2 over 3. But my new slope, because it's going to be perpendicular, then it's going to change. It's going to change to that opposite reciprocal. So it's going to be negative now, and the 3 is going to be on the top, and the 2 is going to be on the bottom. From here on out, it's just like the last one. I'm going to start off the same way, y equals, but I'm going to put my new slope in there, and that's going to be a negative 3 over 2x. I don't know what my b is, though. It's not necessarily going to be 1, because that has nothing to do with it. But because I don't know, I'm going to put a b. That's the placeholder until I can figure out what it is supposed to be. And so now I'm going to plug in my two numbers for the x and the y and figure out what's left. So 2 equals negative 3 over 2, put x in parentheses, which is 9 plus b. So 9 times 3 over 2, well, 9 divided, or actually 9 times 3 is 27 divided by 2. Okay, and the reason why I'm getting no weird numbers is because I changed the problem and it's not going to turn out to be as pretty, but that's okay because I wanted to show you how this perpendicular thing works. So I would do the same thing. I'm still going to add this thing to get this over here. So 27 over 2, and so now we're going to have to deal with the fraction, but we can do it. This 2 right here becomes a 4 over 2. Because I need to get this to be the same denominator, and I get 27 over 2. And so I'm going to add 27 over 2 and 4 over 2 to get 31 over 2, and that equals my b. Okay, so now that I have that, I'm just going to put it all together. Y equals, let's see, negative 3 over 2, the same new slope that I had before, and then plus 31 over 2. You could write that as a decimal too if you wanted. It'd be about 15 point something. But I would just leave it like that. That's how you write an equation of something that's perpendicular to something else.